Good morning, class. Good morning, class. If you can hear me, can you please raise your hand? Okay, it seems like everyone is raising your hand. I'm going to call the name. Okay, once you heard your name, you can put down your hand. Wenyi. Put down hand when I call your name. Wenyi. Put down your hand. I mean, put down the raising hand button. Jia Kai. Ken Yin. Jessie. Jia Qi. Yi Ching. Jasmine. Jia Yin. Jasper. Rachel. Jun Tong. Yon Yi. Yu. Put down hand when I call your name. Yu Sheng. Wayang. Clarice. Kelvin. Yu Hin. Qi Ming. Yi Hong. Kai Yang, are you there? Kai, are you there? Okay, class, I have some network problem here. Give me a minute to retrieve it. Okay, when I'm retrieving it, right, we are going to discuss self-practice 1.3 first before we do the new topic. So I would like you to put down the questions that you want to ask. Okay, I want you to write down the question that you want to ask regarding self-practice 1.3, which is the exercise that I asked you to pass up. By the way, this class has 7 students, still has not passed up your work yet. Please do it before I assign you the next exercise. So because of the networks not very stable, I need to turn off my camera. Okay, I need to turn off my camera because of the network issue, yeah. And please write down the questions that you want to ask. Please write down the question that you want to ask here. I'm going to show this, share this screen. Self-practice 1.3. Any question that you want to ask? You have tried this question already, right? So any question from here that you have problem to understand? Anyone would like to ask any question from here? No question? Okay, if there's no question, then okay, 1B. Okay, then any other more questions? No, just 1B. Okay, let's look at 1B first. You guys sure there's only one questions to answer, okay? Okay, given the image B, image of B is 2B, find the possible values of B. Image of B, B is the object, correct or not? B is the object. Okay, means that when you substitute X by B and then put into the calculations, put into the equation here. Okay, like that. You say that image of B, this B stands for the object. Okay, this 2B is the image. Meaning to say that when you substitute this B into X, because X also object, okay, X also object. And then when you do the calculation here, the outcome of calculation, okay, is image. So in short, it means that you substitute B inside X here. Okay, you change this X become B. Then the final outcome is 2B. Okay, so what we're going to do here is see this one's the left hand side, this one's the right hand side. So for left hand side, we got to change this part. Okay, we got to replace it by 3 plus 6 divided by B minus 1 equals to 2B. Then here, we got two ways to do these questions. So in my recommendation, we multiply all the equations by B minus 1. The whole equation, you multiply it by B minus 1. And then, what are we going to do here? We got two terms, two terms at the left, one terms at the right. So all this must multiply with B minus 1. So what happens if you multiply with B minus 1? 3 multiplied with B minus 1, we can just write as 3B minus 1. Then 6 over B minus 1 multiplied with B minus 1, you cancel off already, right? Then plus 6. Then 2B, you got to multiply with B minus 1. Okay, you don't see any denominator here. Okay, you don't see any denominator here. After that, all this round bracket, you open it up. 3B minus 3 plus 6 equals to 2B squared minus 2B. So this is what this is. This is quadratic equations. So quadratic equation, how do we solve it? We must let it equal to 0, right? So let it equal to 0 means that you move all these numbers to the other side. 2B squared minus 2B Bring this 3b to the other side minus 3b. Okay, negative 3 plus 6 is equal to 3, right? So this 3 you bring to the other side because minus 3 equals 0. And we will have 2b minus 5b. 2b squared minus 5b minus 3 equals 0. Do factorization. 2b times 3 equals 6. 1 times b equals 1. Negative 3, positive 1. Then we will have 2b plus 1 equal to 0. B equals to negative 1 over 2. Or b minus 3 equals to 0. Therefore, b equals to 3. So that's why the question gives you the hint on where these proves that you will have no answer. Okay, very legal. Any more questions? Oh, okay. Question this 1b. Is everyone okay? If you understand this part, can you please raise your hand? Okay. Put down your hands. Your last call. Anyone has any question here? No problem. Okay, if no problem, then we will proceed to today's lesson. Composite function. We sometimes to open the file. Okay, before we see this diagram, right, let's get some basic idea first. Okay, let's get some basic idea. If let's say f is a function of x where x map onto 2x plus 1. Okay, we know that fx is equal to 2x plus 1, right? If we change this x to become a, what happened? Anyone can answer me? If we change this x become a, what will be the outcome? All right, it will become 2a plus 1, isn't it? So this variable, this x change according to what is in the bracket, isn't it? So let's say what if we change f g, what will happen? Okay, all right. So it is 2g plus 1, isn't it? What if we change to x plus 1? What will happen? Okay, correct. You change also, you change it become 2x plus 1 and plus 1. After that, you open up the bracket, you got 2x plus 2 plus 1, and the final outcome is 2x plus 3. Okay, so this one, it is because we will see it is also a kind of function in terms of x. Okay, in terms of x. So when this is a function inside a function in a function, yeah, this one we call this a composite function. When there is a function composited in a function, okay, composited in a function, there are two functions, a function in a function, we call them the composite function. So for this example, are you okay with that? Understand? If you understand, can you please raise hand? So what does it mean by composite function? Composite function is that there is a function in a function. We call that a composite function. Okay? Then hands down. Then we look at this diagram. So this one is a line notation, okay, or line diagram. Okay, a line diagram. So the first line we call it an x value. The second line we call it a y value. The third line we call it a z value. Okay, so from x value to y value, we call it the function of g. Function g defined as, okay, function g defined as g is a function of x mapped onto x squared like that. Okay, and then function f, the definition of function f defined as f is a function of y. Okay, you see this is y and maps onto y plus 2 like that. Okay, so from 1 we maps on 1. Okay, starting from 1 maps on 1. Then the question is, and then 1 to become 3, how to become 3? Because you use 1 plus 2 become 3. This one is because of 1 square. Okay, 2 map onto 4 because of 2 square. And then how to get 4 to 6? 4 to 6 is 4 plus 2. And then composite function will tell you that I don't want to know about y value. Okay, I don't need to know about y value. I want to know how to x straight away get to z. Okay, how to get x value map onto z. Okay, the way of value x map onto z. Okay, that is the composite function. Okay, that is a composite function. So means that I don't want to bypass this y value. They don't want to know what is the y value. I just want to know how do I get x straight away get to z value. So that is a way, the method to get x value straight away map onto z value. We call it the composite function. Any question regarding these slides? If you shall understand, this is the concept. Okay, you understand this is the concept. Okay, the way to get x value, bypass the y value, straight away to get z value. That is the function that tell you about the composite function. Okay, understand this part? If you understand, you raise hand so that I can move on to the next page. Okay, put down your hands. Okay, so at first, when we look at into this one, is a line diagram, right? Line diagram. And then if we change to set notation, actually telling the same thing now. Okay, set notation, they're telling you the same scenario. From x value to get to y value, then from y value get to z value. Okay, because from x to get to y, right? They're using y equals to x squared. No? Y is equal to x squared. And z is equal to y plus 2. Okay, if we want to know from x straight away get to z, you can see straight away get to z value. Okay, because z equals to y plus 2. Okay, and then y is x squared. So when we use this one, substitute, we substitute sub inside. Okay, sub inside. Then we know that z and x, the relation is x squared plus 2. Okay, This one, this x squared plus 1 is composite function of just now g and f, right? G and f is a composite function of g and f. But which one is inside of which one when we say composite function? Remember just now, fx plus 1. Okay, this is another function composited in f. Okay, this is x plus 1 is a function composited in f. Remember the first slide, yeah? Now, the question is, in this situation, which function is composited in which function? Okay, I say again, which function composited in which function? We got two functions here, g and f. Which function composited in which function? Then you see, because x to get x squared, we call it g, right? We need to say that f is what? This y is what? Y is actually gx. Y is gx, right? And then this is function y, okay, function f. From x to y is a function f. Okay, means that z is fz is fz. And what are we doing here is we change this y value, fy. F is fy. Okay, after that we change this y become x squared, right? We change this y become x squared because y is x squared, right? Okay. Then you will see that it's actually y. What is y again? Y is g, isn't it? So we put the g inside here. You will see that it is actually g composited in f. My question was, which function composited in which function? It is g composited in f. Therefore, from x straight we get to z value, this arrow, we call it a fg. Okay, from x straight away to get to z value, we call it a fg. Think about it. I'm going to ask you another question quite related to this one. You see, again, from x to y is function g. Y to z is function f. So from x to z, this is the other way around, is fg. When we say fg, right, it's not mean f times g. It's actually mean f composite g or g composited in f. Okay, think about it. Now I'm going to show you another diagram. Okay, sorry. Okay, this scenario. So from this x, y, z, okay, the function to map x onto y, we call it k, and then k map onto z, we call it h. So what is the function? What is the composite function which map x straight away to z? Anyone? What do we call this kind of function? What is the function that map x straight away to z? Any more answer? Respond to me, yeah. So from x straight away to get to z, H first and K composite inside that. Okay? Or we can write HK. Okay? Or we write HK. Try another one. Let's say 3 4 sets. F, G, H. Okay. W, X, Y, Z. Okay. What is the function to get to Z straight away from W? Anyone? What is the composite function get W straight away to Z? Okay, correct. We go backward. So it is, the backward means that H first, then G later, then F later. Correct. Got that. So this is the concept of composite function. So far, any problem? Understand? How do we write this composite function? As for now. If you're okay, can you please raise your hand? All right, hands down. We'll see. Okay, this is the way we write it. Okay, this is the way we write composite function. Okay, so FG, sometimes they don't even write down the bracket X. So FG means that the GX is composited in F. So what are you doing to do is the working FG, you will change this X become G, right? This X become G, G plus 2. And what is G? G is X squared. So that become X squared plus 2. Okay, that is the correct way to, the correct proper working to write down the composite function. Okay, FGX equals to X squared plus 2. Okay, let's see more example here. So this example saying that F defined as 2x, and GX defined as X squared minus 5. Okay, A, FG. FG means that G composited in F. Then what are we doing is we look at F, we change this X become G, 2G. Okay, after that, what is G? G is X squared minus 5. So we got 2x squared minus 5 in the bracket. Open up the bracket, 2x squared minus 10. Minus B. GF means that F composited in G. Okay, F composited in G. So if we have G x equals to X squared minus 5, then change this X become F. This X also change to F. Okay, eventually it become F squared minus 5. So what is F again? F is 2x. So you substitute. Remember, when you substitute, you need to give bracket. Yeah, 2x squared minus 5. Open up the bracket. 4x squared minus 5. Okay, part A and part B first. Anyone has any questions to ask? If you don't have problem, you raise hand. So more than half of the class okay, then we continue. Put down your hands. Okay, C, f squared. And again, f squared does not mean f times f. Okay, f squared is not f times f. F squared is actually f composited in f. It means that this one you change, this x you change to f. This x also change to f. So become 2f. Don't get confused about this one. Some people, hey, why f bracket f not s times f? No. In function, f bracket f means f composited in f. Does not mean f squared. Yeah. In this case, it's 2f. Don't get confused about this. Why is it 2f? Because from here, yeah. And then what is f again? F is 2x. So you replace this f by 2x. So become 4x. Like that. Same goes to g. Okay, g squared means that g composited in g. Okay, it means that you will change this x become g. This x also change it to g. So it becomes g squared minus 5. What is g again? G itself is x squared minus 5. 10 squared minus 5. Do the expansion. Open up the bracket, we got x to the power 4 minus 10x squared plus 25 minus 5. So g squared x equals to x to the power 4 minus 10x squared plus 20. Okay, C and D. If you have question, you write down. You write down your question. If you don't have a question, please raise your hand. If you have a question, write down. If you have a question, raise your hand. It seems like some of you has having some problem, but well, I'll wait for your questions. No problem. Not even half of the class raising hand means that some of you may have problem. Never mind. Think about it first. Of course, need some time to digest lah, right? Only 7 of you understand C and D. Yeah, what's wrong? What's going on? Okay, let me just put down the step. Let's say this is first step, second step, third step, fourth step. So 1, 2, 3, 4, 5. Okay, you tell me which step that you do not understand. I can repeat. If you understand, you raise hand. But because like, which question you mean? On D step 2, 3, 4. 2, 3, 4. Step 2, because of the original function is x squared minus 5. The original function is gx equals to x squared minus 5. Then g squared means that g composited in g, we will change this x become g. Then become step 2. And then step 3, what is g again? G originally is x squared minus 5. So we substitute this g by x squared minus 5. And the square still remain here. Square still square, but g itself is x squared minus 5. Then step 3. Step 4 is the expansion. The expansion, if you can't skip the step, then you just add one more step. 2 more steps here, sorry. X squared minus 5 times x squared minus 5 minus 5. Then do expansion, x times x squared times x squared, x to the power 4. X squared times negative 5, negative 5x squared. The other way around, negative 5 times x, negative 5x, right? Then negative, negative, positive. Once you simplify, it will become this part. Reaching, okay or not? So guys, any more question? If you don't have question, you raise hand. Okay, now have more than half already. So some of you not very responding. I hope that you're still around here. Okay, that's all I want to talk about. Then we will do this question together for a short while. Whatever we couldn't finish discussion today, it will be your work. You will do it by yourself. Okay, take about 1 or 2 minutes to write down self practices 1.4, page 14. You have to copy the questions. You can start answering already. Okay, I'll let you to try, let's say 2 minutes. Okay, we will resume the discussion in 2 minutes. Yeah, at least question number 1. Okay, question number 1, 2 minutes time. Try by yourself. Think about it first. Okay, shall we discuss? Question 1. What do you think about fx? F is a function of x which map onto what? Anyone? From the diagram. Okay, 3x, right? How about B? Gfx is a function of x which map onto what? Okay, correct. 2x minus 7. Or the answer from Bondy. Anyone has any question about this? Question 1. It's simple as that. Okay, if question 1 no problem, raise hand. If you have problem, I'll wait for you to write down your questions. Okay, most of you okay. Then put down your hands. Okay, so let's do question 2. 2 is a bit long, so maybe A, B, C, D, I only explain one question, sir. Because each of the question need to do four parts. And each sub question need to do 4 parts. So anyone want to ask anything? Which question? A, B, C, D, which question want to do? We do together, the rest you try it by yourself. Oh, I give you some time to try it first. Let's say 5 minutes. 5 minutes to do. This one is corresponding to the example just we've seen just now. And for A, B, C, D, C and D, you need to be aware of because it has reciprocal functions. And reciprocal function means that you need to have special domain. So when you write the composite function, also you need to write down this special domain. Okay, where denominator cannot be equal to 0. For example, x minus 1 cannot be equal to 0, then x cannot be equal to 1. Why is it x cannot be equal to 1? Because denominator cannot be equal to 1. Okay, so be aware of this one. Okay, question 2. Any question you would like to ask? Okay, 3 more minutes. If you don't have question to ask, we'll proceed to question 3. So try it another 3 minutes time. Question number 2, which question that you want me to discuss with you? Actually, you should try first, huh? Okay, so for the next 10 minutes, right, I will let you to try this question by yourself. I will still around. Okay, if you have question, you ask me. But if let's say you don't have question, want to ask me, okay, you can dismiss. I can let you to go 10 minutes early. But let's say you want to do some question right now on the spot, and then if you find out any question you want to ask me immediately, I am still around. Yeah, I am still around. Okay, if you don't have any questions to ask, you want to leave early, okay, I'll let you to leave early. Okay, anyway, and again, I'm still around, yeah. Please ask me question if you have any. Anyone want to ask any question? Well, today teacher no business. No one want to ask me questions. Question 1B. Later. Okay, so what's your problem? GFX, you see from P to R, right? From P to R is already GF. From P to R is already GF. And then 2x minus 1, this x is coming from this x. Understand? This x is actually coming from this x. Okay, you can see that this x is actually from here. And then from from P straight away to R, P straight away from R is GF, is GF. And then this x is from this x. That's why here, different with the previous question. The previous question in the middle, this one we call it y, right? So that's why GFX just straight away 2x minus 7. Okay or not? You shall. You see? If Q is y equals to 3x, then R is 2y. If Q is y equals to 3x, and R is 2y minus R, yes, correct. That is different, correct. And then R will be, okay, class, if you don't have question, right, you may dismiss. I'll see you tomorrow, right? Tomorrow we have class. So see you. Thank you, class. Do you have a question to ask? Gmail.